Hi, I'm Margot, and today I will give you a full feature overview of Cloudomation Engine. Cloudomation Engine is a code-based general-purpose automation platform. You can use it for data integration, for infrastructure automation, for release and deployment automation. You can also use it to automate business processes like payroll, like order management. So it's really a general-purpose platform that has a lot of different interesting features, and today I want to give you a brief overview of all of them, or almost all of them. So first of all, I'm gonna log in. When I log in, I see my dashboard. This is a demo workspace. I've prepared some demo content here. What I can see immediately is which automated processes ran recently, how many of them were successful, how many of them were not successful, and some other useful quick links to last edited by me, for example, last executions, things like that. On the left-hand side, I have my main navigation. I have projects and I have bundles and I have my workspace. Right now I'm on the workspace node, which gives me an overview of everything. Projects are a way for me to group resources that I use to describe automated processes. Projects are used to collect resources for one use case. So for example, here I have a project for an onboarding use case and another one for release automation. Bundles are pretty much the same thing. There are also buckets or ways to collect and structure content on the platform, only that bundles are managed via a bundle manager and are distributed through a bundle repository, meaning that this is a way for us to provide content to customers, to users. So bundles can be imported, updated, and restored. And they contain standard functionality, templates, things that many customers use. And also we have an internal Cloudomation bundle repository where we distribute content that we need internally, like for example, our customer workspace operations or our CI/CD pipeline. Let's take a look at the project. So here I have prepared a demo project for this demo. And the first thing I want to show is the Git integration. So on each project or bundle or workspace, you can enable Git. In this project, I already enabled Git. I can name a branch, I can switch branch, I can create new branches here. I can also manage the Git repository, so I can choose a repository name. I can take a look at the Git URL, so I can use this to actually access the Git repository from my own IDE, from my own machine, so I can SSH into the Git repository, and I can make I can pull content, I can commit content, and I can basically also maintain and work on my Cloudomation content in an offline editor or IDE. I can also disable Git and remove the Git repository. I will not do that right now. Obviously, I can also commit, and I can bulk commit many changes in many different resources. And I can also reset to the status in Git. This means that I can use the entire version controls functionality of Git within my Cloudomation workspace. I've already talked about resources. So resources, everything I create on the platform is a resource. Everything that I as a user can create is a resource. There are different resources that enable me to describe the different aspects or parts of an automated process. At the very heart of all automations is what we call a flow. The flow is a Python script that defines the process logic. So in the flow, you define in Python what should happen, when, where, and how. So this is really the process logic. An automated process typically consists of more than one flow. We recommend to keep flows as atomar as possible. So one flow should include one step or one task within an automated process. Here, this flow is actually a very small flow, so it's really just one connection to a joke REST API, and it then tells me a joke. I can maximize the editor and take a closer look. So this is really a very small script. As you can see, it uses standard Python with some Cloudomation specific functionality. So for example, this connect is the Cloudomation feature for using so-called connectors, which I will explain about in a bit, which allow me to configure connection to APIs, servers, any other system or software outside of the Cloudomation platform. I also have available IntelliSense within this editor, so I can get some direct information from the documentation about how this actually works and which parameters I have available, and these kind of things. I also have a visualization, so this is actually quite useful, not so much when writing a flow script myself, but rather when taking a look at flow scripts that maybe colleagues wrote or something I wrote a long time ago, to quickly get an overview of what's actually happening here without having to dig into the code. The visualization helps to get a quick overview. This is updated as I write the code, and whenever I save, this updates the visualization. And the visualization is actually automatically generated from the syntax tree of the script. In my editor here, I also can set breakpoints, and I have the option, if I do set breakpoints, to run my flow in a debug mode, or a debug mode with fixed breakpoints. I can remove all breakpoints. I can also run it in dev mode. Dev mode is development mode, which doesn't cost anything. So our licensing model is based on connections to third-party systems. So whenever I run a flow that does a connection to a third-party system, like in this case here, it connects to a REST API. This will cost a connection. If I run it in dev mode, it doesn't cost a connection, but dev mode can only be used interactively. So when there needs to be a user that's logged in and that's active in order for process to be run in dev mode. Otherwise, they will be paused. So unattended processes cannot be run in dev mode. They run in productive mode, which costs connections in the licensing model. So that is the flow. The flow defines the automation logic. What I can do in addition to the actual logic, I can add wrappers. So wrappers are actually a way to, like the name suggests, wrap a flow, but also a connector, a scheduler, anything that can create an execution, anything that can do something on a platform. I can add wrappers to it, which wrap the entire thing with meta logic. So this is functionality that is useful for automation, but isn't really part of the business logic or of the process logic, and therefore should be contained in a different resource. For example, there is a cache wrapper. A cache wrapper means that data that is being requested by a flow or a connector or anything that executes anything, I can choose whether or not they should actually get fresh data or cached data. So for example, here this tells this flow calls a REST API to get a choke. I could, for example, add a cache wrapper and say, I only want to actually call the REST API once per hour. If there is an older execution of this flow or an older connection to this REST API that is less than an hour old, please take the response from the previous call, return the same response, so return the cached data without actually connecting to the third-party system. This can be very useful when I, for example, want to manage how much load an automated process is puts on a database. So I can say, I already know that my data is only getting refreshed 3 times a day, for example, if there is some batch loading into a master data data warehouse, something like that, then I can say so I know it gets refreshed at maybe 6 a.m., 12 p.m. and 6 p.m. So between that, I can say I don't actually need to do fresh requests. I can just cache the data and reuse it, and any process on the platform can get this data without having to actually request data from the database. There is also a check wrapper. The check wrapper checks inputs and outputs. So I can define a schema and say, okay, the input data has to conform to the schema, and if not, throw an error or a warning, or try to coerce the input and output data to the schema that I defined. This is specifically like a check wrapper on steroids, or a bit of an advanced version is the validate wrapper, which has a learn mode. So I can add a validate wrapper, which then I can put in learn mode and run a flow several times. In this time, it learns what the input and output schema looks like. After a few runs, I can say, okay, now I put the validate wrapper into the force mode, so that it actually enforces the input and output schema and checks against it. I can also configure what should happen if the validation fails. So if this should throw an error and actually abort the process, or if it should just throw a warning, or if there is some specific logic that I would like to execute if the input or output validation fails. For example, I can specify a retry, which again is meta functionality. I can add a retry wrapper where I define a retry logic, which can be retry for 3 times, then fail, retry for 10 times, or then fail. You can also say, okay, retry for 3 times, then wait for 5 minutes, then retry another 3 times. It can also say retry for 5 minutes and then abort, anything like that. In combination with that, it's also very useful to have a notify wrapper. The notify wrapper notifies me. Again, this is fully configurable, so I can say notify on success, on error, on warning, on a specific combination of things that happen in the flow script. So these wrappers actually kind of observe the execution of the flow, and any status change, for example, can trigger a wrapper, for example, a notification. I can also add a rollback wrapper. A rollback wrapper allows me to specify conditions under which a rollback should be triggered. So if a specific condition is met, for example, if a flow fails, but it can also be other conditions, the rollback wrapper triggers a rollback flow, which restores the previous status in third-party systems. Very interesting. I can also specify a mock wrapper. It's kind of related to the cache wrapper, but much cooler because it allows me to basically mock or fake third-party systems. So I can say, for example, this little flow where I call a REST API, I can say I put a mock wrapper around this, so it doesn't actually connect to any third-party system or to any REST interface. Instead, in the mock wrapper, I can define what should be returned as a response when this REST call is executed. So it can actually return cache data, so previous responses. I can also specify that it should return the response from a specific execution. So, for example, when I catch an edge case or an error, and I get a weird response from a third-party system, or get an erroneous case, and I know I need to be able to handle this case, but I only catch it once. Then I can use the mock wrapper to say, okay, set now the response to this specific execution, and then I can work on debugging this or handling this error without actually having to reproduce it again and again. Or I can also manually define a mock response. So I can specifically say, okay, I know these edge cases can occur, even though I don't have real data to support them. I can build them and set the mock wrapper to return this response, and then I can develop against it. So those are wrappers. Wrappers are very beautiful and wonderful, and wrappers are also distributed in a wrapper bundle. The cool thing is that, as with a lot of things on the Cloudomation platform, the wrappers are actually also based on flow scripts. So the wrappers are all, here you can see the wrappers, they're the same that I just described. You can also take a look at them, so you can actually see the specific logic that is implemented in each of those wrappers. You can see this is already slightly more complicated than my choke flow. Here you can see there is some logic to this. You can also, of course, modify them, make your own wrappers, copy them, and adjust them to your own needs. But the cool thing is, since they're all based on flow scripts and it's all Python logic, this is really highly customizable and also very transparent. So you know exactly what happens, and you can choose to adjust or customize this to your own needs. Okay, so now we talked about projects, bundles, the Git integration. We talked about the flow script itself, the visualization, the IntelliSense, the breakpoints, the development mode, the debug mode, and we talked about wrappers. Now, what I want to do is actually execute a flow, so run a process. There are 3 ways how a process can be triggered on the Cloudomation platform. One is, actually there are 4, but let's talk about 3. One is interactively, so a user logs in and presses the run button. The second one is via a webhook, and the third one is via a schedule. The fourth one would be via the Cloudomation Engine REST API, which can also create executions. And the fifth one, obviously, is also that executions can call each other. So an execution can start an execution. So let's do the first thing. I logged in. I, as a user, press the Run button. Running a flow creates an execution. The execution is the instance of this specific execution of the flow script. In this case, it calls a REST API and tells a joke. So what joke does it tell me? What did the grape do when he got stepped on? He let out a little whine. It only works when you actually pronounce it, because wine and wine, whining and wine the beverage. Yeah, this is a dead joke API, so it's not very good jokes typically. In any case, so execution. I'm now at the execution object. This again visualizes for me what is done in this execution, what process is actually being executed. In this case, it only consists of two steps. One is the actual execution of the flow, and the second one is the execution of the connection. So this is the connection to the REST API, this joke API. Each connection to a third-party system automatically creates its own execution object, even if it is defined within a flow script, because it has its own logging. So each execution that connects somewhere else has a connection execution object, which looks slightly different. You notice here that the connection execution has only input-output logs and some additional fields, while the flow execution has some more fields. So for example, the flow execution also includes the script that was executed. In the connection execution, I can see specifically which input and output was received, and I have logs. So this is very important. Obviously, the logs very specifically log what was executed when, shows responses. In this case, only, not a lot, but still, it's important to have these logs. In the flow execution, I also have the inputs and the outputs and the script. I also have the children, so any sub-steps, any child processes that are triggered by this are logged here. I have a search and everything. In this case, it's only the REST connection. I also have logs, same as with the connection execution. Here you can also see the specific lines that were called when. You have links to the specific execution object, which is always this same object, but can also be child executions. And very importantly, I have save points. Save points, much as in a computer game, allow me to go back to any one of these save points and reload the execution, restart it from this save point. You can see that save points are set quite often. They are set whenever the flow API is called, so whenever Cloudomation specific Python functionality is used in a flow script, or whenever a connection to a third-party system is established. So before a connection and after a connection, a save point is always set. Save points, like I said, can be used to reload an execution and restart it from a specific point in time without having to specify any inputs, outputs, or anything else, because this really is the entire execution stack persisted in the database. So you don't need to, you just click the button. You can do that. Let's restart it from here. Now I loaded the save point. It redid it from there. Amazing. Just now it went through the entire thing. The output should have changed. Actually, no, it didn't change because I restarted it after it had already established the REST connection. But going here and interactively reloading a save point is actually not the main benefit of save points. The main benefit of save points is that they make executions extremely robust and very scalable. In terms of robustness, since save points are set at a very fine granular level, if the system is interrupted, if there is any issue, even if there is major outages like electricity gone from the server room or something like that, God forbid, should never happen. But if it should happen, or if the server crashes or any other severe outage happens, as soon as the system reboots again, it will just continue running the processes without losing any data. Because the save points actually persist the entire execution stack, including all data that is needed, it means that only in between save points, so only these two lines in between, which don't really contain a lot. This is a volatile state, but every save point that is set is a point where a recovery can happen. It also makes it very scalable because at any save point, the save point is persisted in a database. Then a worker process comes and takes this save point and does the next step until the next save point. So this is the handoff between worker processes, and you can have many worker processes working on the executions in a workspace. So you can really have a very efficient, fine granular handoff of work between these worker processes, which makes it very scalable. Yes, so I said one way to start an execution is by going here and clicking the run button. Another way is to actually schedule it. So again, scheduling is a fairly basic feature of an automation platform. Our schedules, again, are based on flow scripts. So there is, like the wrapper bundle, there is a scheduling bundle where you can see our schedulers, which are, again, Python scripts, which you can take a look at. You can modify them, you can create your own schedulers. I will do a bit of a deep dive into scheduling at the end of this video. But you have standard scheduling functionalities. You can say every Tuesday, every 10 minutes, every day of the week, unless it's a holiday in Austria or things like that. So the third common way to trigger a flow is via a webhook. Every flow has a button that says create webhook. I will click it now and I have created a webhook. A webhook triggers a flow. A webhook is a web endpoint, so it's an HTTPS URL that when called starts a flow. I will call it my choke webhook and save it. I will not commit it to Git for now. I can edit the webhook security, so I need to enable it, and then I need to define which security measures I want to apply to it. So, for example, I can set a key that then has to be supplied to call the webhook. I can also require the login token, so Cloudomation Engine login token. I will do this. I will choose the login token because I already have it set in my browser, and it's the simplest for me to show right now. I need to confirm with my password, so this is really to make sure that webhooks which are exposed to the internet are not accidentally exposed, that they're not exposed without a key, that they're not enabled automatically, but you actually need to actively do that and confirm it. And then I have this web endpoint and I can simply call it. So I can call this webhook. I just read a book about Stockholm Syndrome. It was pretty bad at first, but by the end, I liked it. Haha, okay, like I said, very funny. Actually, I think I need to go out of full screen mode for the browser now to go back. So you can see I just called this webhook URL, and in the flow, tell a joke, I defined what the webhook response should be. So here at the end, I said return this webhook response body equals joke. So the joke is the joke. The joke webhook triggered the flow. It also has a log where it tells me the webhook security configuration was changed. Some formatting issues, I will make a ticket. The webhook was called successfully. It created an execution object, and the execution succeeded and returned the HTTP code 200. So the execution was creating, the webhook created this execution, the one about the Stockholm Syndrome joke, again, which has its own logs telling me specifically what happened when. And it also, here in the details panel, I can actually see that it was created by the joke webhook. So really, this is very transparent what happens when, where, how. Here you can also directly open the webhook from the flow execution, going back to see how it was triggered. And like I said, in the flow script, you actually define the webhook response. So this is actually a very powerful feature in the webhooks because you can take any inputs. So any input, any parameters, any data that is sent to the webhook is forwarded by the webhook to the flow. In the flow, you have Python where you can define what should happen with it. And then you can define a custom output, a custom response. So this webhook can return any data as well. So for example, you could, to the webhook, you could send a body payload with a JSON, with JSON data. The flow script can then process this data and return another response with a JSON body payload with processed data. So this is really a way for you to create your own custom APIs. It's a custom CRUD API. It can take also any kind of requests. It can take GET requests, but also POST or PUT or delete or update or read or whatever. Yeah. So a webhook is very flexible, a very flexible way for you to define custom APIs using Cloudomation Engine. I also have a small demo where I can show in a bit more detail what this could mean, how this could be used. But let's stick with the feature overview for now, and I will go into a bit more detail about how to use webhooks later on. Okay, so the next thing I want to show or talk more about are connectors. Here we connected to a REST API. REST APIs are useful, very ubiquitous, but obviously they're not the only way to connect to third-party systems. On Cloudomation Engine, you have the ability to create a whole range of different connectors. You can also refer to our documentation on docs.cloudomation.com. Let me show here, docs.cloudomation.com, to go to the connector types reference where you can see all the different connector types that are available and what they can do, how they're parameterized, and so on. So there are a lot of different connectors available. A connector, let's take a look at one. This one is a PostgreSQL connector. A connector is a way for you to configure how to connect to a third-party system. So this can be a database, this can be a REST API, this can be an SSH connection, or Samba file transfer, or really anything you need. And the useful thing about connectors is that you configure how to connect to the system once, and then in all your different processes or flow scripts, you just refer to this connector, use this connector, and don't need to redefine how to connect to this PostgreSQL database. Which means, first of all, it's much easier to do and much faster to develop. But it also means that if there are changes, so if there is any change to your connection, you only go to the connector, change it, and it's automatically used by all the different processes. You don't need to go into 100 places and change something if there is a change to your connection. Connectors also have a few nice features. So in the connector, you can define a connection to a third-party system, but you can also just partially define it. You can also, in the flow, then choose to override some aspects of it. For example, if you have a database connector, you can already define the query in the connector. If you have a standard query that is always run, but you can then also change or adjust or update or apply different query in the flow script. Or you can also not define a query in the connector, but require this to be defined in the flow, in the execution. Okay, so a connector, like I said, is a way for you to configure a connection to a third-party system. In this case, this is a PostgreSQL database. So you have a host name, you have a port, which you can either specify via service name or port number, and you have an authentication method, in this case, username, password. You can also set some additional properties. And what you can see here already is that username and password, first of all, password is a protected field, but this, even if I was shown, it's not the password itself, it's a reference to a vault secret. So Cloudomation is actually integrated with, at the moment, two different secret backends. One is the HashiCorp Vault, which is the one that is used here. HashiCorp Vault is an open source, state-of-the-art secrets management system. The second one is Devolution's secrets management. Using the vault means that you set up a so-called vault configuration. Once you connect your workspace to a vault, you define which levels of access it should have on the vault, and then you refer to any vault secret simply by saying vault.secret or devolutions.secret, then the name of your vault configuration and the path to the secret in the vault. And then secrets are actually never shown in the Cloudomation Engine user interface. They're never stored in the Cloudomation Engine database. They're only fetched at runtime from the vault, used and immediately forgotten. So this is a way for you to very securely manage secrets in Cloudomation Engine. Again, it also has the useful benefit that any changes in secret, so if you do a key rotation or if a password changes, you can do that in one place, namely in your vault, and there you update the secret. Any connection made through the Cloudomation Engine platform will fetch the fresh, up-to-date secret from the vault at runtime. Oops, I clicked on the documentation link. Okay, then one thing I also want to show here is the form view and code view. You've seen this before also in the execution object. It's actually available on in many places on the Cloudomation Engine platform, and it goes back to the fact that Cloudomation is a code-based automation platform. So all the data you see here, almost everything that is displayed to you in the user interface is actually structured data in the background, which is machine readable, which is transparent, can be seen by you. It can also be, it's also in Git, so you can also edit it or create it automatically because it has a specific structure. You can also see most things in code view or in form view. The code view is, so the data is mostly YAML structured data or Python scripts for the flow scripts. Here you have the same code editor as everywhere else, and you can see this is what the connector configuration for a PostgreSQL connection looks like in YAML. The form view is mainly to improve user experience because it's much more discoverable. It actually tells you which fields are available. You have drop-downs to select possible values. You have defaults are displayed. In this case, null is the default. You can reset it to the default. You can clear the field. So it's just for user experience, really. One other thing you can do once you have defined a connector is you can analyze and test it. So that is obviously very useful. You work on configuring a connector and then you want to see if it works, and you just click test and it will test whether or not it works. Another bug here, well, it's work in progress. I'm actually showing you an unreleased version 10. It's not out yet. The connection test succeeded. So amazing, I know that my PostgreSQL connection was configured correctly. But what I can also do is I can analyze the PostgreSQL database. So in our projects, we found that one challenge when automating across many different systems is that often for any third-party system that we need to work with, that is a part of an automated process, we either have no documentation of the interface or it's outdated and not correct. So for example, if we need to connect to a database, we don't know what the database schema is, we don't have documentation, so we decided, why bother? We will just go and take a look directly. So you can actually analyze the database and you get the database schema. I already did that before, and I have the analysis data saved with the connector. It also tells me when the last analysis was done, and then I have the database schema right here. It tells me which tables I have available, which columns, which data types they have, and so on and so forth. And I can use that then to develop against this database. Obviously, depending on which type of connector you have, which type of analysis data will be returned is different. For REST connectors, for example, it will try to find an open API specification. For an SSH connector, it will just read out some basic information about the system, like the operating system, available disk space, and things like that. For some connectors, we also have actions available. So for example, for a PostgreSQL database, you can add a schema monitoring, which means that you regularly check if the schema that you read out has changed or not. Very useful because it means that you can make sure that you know that something has changed before it crashes processes. You can also run a vacuum or a full vacuum, and you can schedule a vacuum of the database. This again is based obviously on flow scripts. So you can create your own actions, you can define your own actions, you can add your own actions to this button here, and you can also just customize the actions that are already available and take a look and modify them to your needs. So again, this is all very transparent. It's all based on Python flow scripts. Okay, so this was schedules. This was, sorry, connectors. I'm actually now pretty much at the end of the basic feature overview. I'm now going to start with a bit more in-depth and advanced features. Let's start with another security feature, namely role-based access control. So on Cloudomation Engine, you have role-based access control available, which means you have roles. You can create a role and you can add permissions to this role. These permissions are on different levels. You can select the operation, so create, delete, read, update, or everything on a record type level. So on all the different records that you have available, for example, you can say there is someone that a role that only is allowed to read users for whatever reason. And you can restrict it on project level. So you can say all projects, or you can allow actions only on a specific project. Once you have a role and it has permissions, you can assign this role. I will delete this again. You can assign this role to a user. Actually not only to users, but to entities. So any entity that can create something, that can do something on the platform, has a role or has roles associated with it, which means this is users, but it's also webhooks, it's also executions. So each execution has specific roles assigned to it, and you can define which roles an execution has. And for each user, you can also decide, or for each entity, you can also decide not just which roles it has, but also if it's which roles are propagated. So for example, my user right now, margot@cloudomation.com, I am organization admin, and I also have the default role, and I can choose to propagate one or both of them. At the moment, I propagate everything, which is not best practice. And a bit laziness that I do this for demos, because otherwise I would have to set this up separately for each demo workspace. I could, and I should, and I will automate this to set up a proper role concept for my demo workspaces. In any case, so what you can do is you can, for example, for a webhook, you can, a webhook also has roles, and the webhook also has roles assigned to itself, which determines what the webhook can do, but it also determines which roles are propagated, so inherited by the process that it creates. And for example, the webhook can have privileges to create executions, but the executions that it creates don't need that privilege because they just need to run. So you can also restrict and inherit less privileges to the executions that the joke webhook creates, or any webhook creates. So full role-based access control available to you, which is can be used to restrict what automated processes can do or cannot do, but also obviously what users can do or cannot do. So for example, I think one of the most common use cases is to say that some people have access to the CI/CD runtime project and others don't. That's role-based access control. Then we also have workspace settings, which allow you to configure quite a lot of things in the workspace. For example, how long executions should be kept before they automatically move to the trash, and then how long they should be kept before they're deleted from the trash, how long save points are retained, if they're retained at all, if you save them, if you save all of them, if you only save the last one, all these kind of things. Also performance tuning you can do here, and maybe my favorite, you can set the color of the workspace highlight. So extremely useful here. Now I have a yellow top bar or a blue top bar. So this is most useful for a situation where you have several workspaces, like we do. We have lots of workspaces internally, and we use them for different purposes. And in order to make sure that I'm not confused, or I'm actually realizing, oh, I'm on a test workspace and not on a production workspace, I can set a different top bar color. Related to that, working with several workspaces, so we always recommend having a test workspace, which is included in almost all licenses, which you can use to test after an update to make sure that everything's running smoothly before you actually update your production workspace. One thing you can also do is you can link workspaces. So there is a so-called sync configuration. There isn't one in this workspace, but a sync configuration allows you to connect two workspaces with each other, which then can hand off processes to each other. So then you can define in the flow the location for each step of the process. And if a process step is set to a different location than this current workspace, and if there is a sync configuration that actually determines how to connect it to this other workspace, you can then have processes being handed over between workspaces, which is very useful to automate across network boundaries. So for example, if you have a demilitarized zone, a network zone in your company that, for example, contains some databases that you need some data from, you can have a workspace there, you can have a process in a linked workspace that is triggered there and runs, and only for the specific step where it needs access to a specific database in a different network segment, you can hand off this execution to this other workspace, which goes and does the one specific step and then goes back to the initial workspace. And you don't need to take care of anything other than to specify location for a workspace, for an execution step in your flow. So there's a location, actually not for the connect object, but when you run a flow execution, there is a location. Actually, there is a, and you don't need to take care of anything other than specifying a location parameter in your flow script. Everything else of how this is handed off and returned is taken care of by the system. And you guessed it, it's done via handing off Savepoints. Very amazing feature. So those are linked workspaces. Cloudomation is also available both as SaaS, as software as a service, and also on-premise. So you can also install workspaces on your own premises. And one way to use linked workspaces is also to connect cloud and on-premise systems with each other. Also, you can use it, for example, to securely expose a webhook in a cloud workspace to the public internet with a key or login cookie protection, and use this to have something in the public internet without actually exposing internal systems or ports to the internet. A very important feature I haven't explained yet. One very powerful feature of Cloudomation Engine is its master data management functionality. So there is a feature, we call it actually custom objects and object templates, which allow you to build a data model for your automated processes in Cloudomation Engine. There are some use cases for automated processes where this is hugely useful, for example, release automation, but also master data management, actually Stammdaten, things like that. And what we have here as a feature is we allow you to model your data that are used, which is then used to trigger automated processes. So for example, here I have a small data model describing release automation. So I have a deployment package, which refers to an application. The application can consist of one or several components. These components can be deployed to one or several servers, and each server has an operating system. There are some additional attributes, so servers can be added to monitoring, for example. Deployment packages have a source where they're fetched from. And let's open one in a detailed view. Each deployment package, for example, also has a version. I can add additional attributes. This can be references to other objects, to other data objects. It can also be just normal input fields. And the very important thing is each object has lifecycle hooks. So on create, a flow is triggered, on update, a flow is triggered, on delete, a flow is triggered. Of course, all of them are optional. I think for server, I have all of them. So when a server is created, the create server flow is triggered. When I update a server, the update server flow is triggered. When I delete a server, delete server flow is triggered. So this means whenever you create a server, you know that you get these values as input values for the create server flow, which then actually does steps to create a server. It also then creates a custom object, so an actual instance of this server specification. This now would be such a my server, such a custom object, which was created by the create flow and which also contains the data, the input fields that was supplied to describe the server. So it has the admin user, it has an add to monitoring flag, it has an ID, it has an operating system. Here I can choose between different ones. It has, of course, again, logs that tell me when it was updated, whether or not this was successful. It has a link to the execution object. And it allows me to keep an overview of which servers I have, how many servers I have, how they were configured, when they were created, what the creation process was, what the input values were that were received. And it allows me to really think about automation in an object-oriented way. So instead of saying I have a process that creates a server and then I have a virtual machine somewhere, which is my server, and on the automation platform I only have the script, the logs, I have a server object here. I have an object that is the thing that ties everything together, all the information that I have about my servers, and it allows me to keep an overview. So this is really powerful, and this is really useful, and this is also extremely customizable, obviously. So you can create your own data models here. You can describe servers, but you can also describe customers. You can describe orders. You can describe shops. You can describe anything you need and use these objects to trigger automation. So when you say you have an order, whenever a new order is created, for example, a webhook is called, which contains order data, you have an object created, which is your order, which ties together all the different things that you have, the input data that were received, all the executions that ran to actually process the order. And you have a list of orders. You can list them and you can see what their status is, and you can remove them again when they're finished. So this is really wonderful. This is again something we developed based on experience in projects that we had, which is that there was also always a need for this information and no place where it was actually kept. So this information about the results, the things, the entities, the objects that were created, updated through an automated process, often there was simply no place for this information to be available, to be kept where you then can take a look and have an overview. So we decided that this was something that's powerful, that's useful, and that we need in our automation platform. And we have it now with the custom objects and object templates feature. Now we really have only very deep dive or advanced features available. Well, maybe one thing also to show is the advanced search. You can search resources, you can search executions. Messages are actually also one thing I haven't shown yet. Let's take a look at messages. In my demo project, I have a messages flow somewhere. Messages, here, message flow. There we go. So this is a flow that creates a message. A message is a form that allows the user to interact with an automated process. So when I run this flow will then ask me a question. Here we go. This is an example message form. This is a more complex example for a message form. Let's go to the documentation to take a look at what else is available. So the basic idea is that messages really are a way for to create interaction with the user in a form for an execution. So for example, if you need an input, you run an execution and you need some input, then you can create a message form to get this input from a user. You can also open messages in an individual window and just see the message without the execution object. One place this is used is in schedules. So let's go and take a closer look at schedules. I'm back at my choke flow right now, and I will now create a schedule. Creating a schedule on the Cloudomation platform is, not surprisingly to anyone who's been listening to this demo for a while now, it's based on flow scripts and on Cloudomation functionality. So it actually uses messages, the message resource, to get the input from the user. This is a lot less beautiful than I would like it to be, and it's going to become a lot more beautiful. But for now, I would like you to focus on the functionality and not the layout, because the layout, like I said, we're working on it. So what am I doing here? I'm scheduling a flow. I decide a name for the schedule. There is a default name, which is just schedule and the name of the flow. There is a setting. Setting is just a way to keep data, to store data. It's a YAML object, and in this setting, the scheduled data will be stored. I can select a time when my flow should run. So let's say maybe in about 5 minutes. I can add additional times. For now, I'm fine with just one time of the day. I can select the days of the week when it should run. Let's say all of the days of the week, why not? Then I will go to the next page and see what other options I have available. This here, again, the thing I'm interacting with is a so-called message form. I said next page. I can also switch to, I skipped the button here. I can switch to recurring scheduling. This would then ask me to give a recurring schedule. So for example, to run every 10 minutes, every half hour, every 24 hours, instead of determining a time of day. So instead of determining a time of day, the recurring schedule would determine an interval between runs. Here I'm at the advanced conditions now. I can select the months when it should run. I can not give anything that it will run every month, but I can also, for example, say, okay, this should only run in August. I can also specify the days of the month if this is specific. So for example, previously I could specify the days of the week if I'm not doing this on a weekday basis, but on a days of the month basis. So for example, it should always run on the 15th. Then I will use this field. I can also determine the calendar weeks if this is how I want to determine it. I can also just leave it empty. So whichever parameters I use will be the ones that are applied. There is an application logic, which is in the documentation. I can also add include dates and exclude dates. So I can say, okay, run every day except for this specific dates. Or I can also say, I only want to include very specific dates. So for example, it should always run on the 15th of the month, but then I also want to run it 2 more times in December. Then I have some advanced additional features, like I can specify a holiday country code. So I can, for example, say run it on every workday in Austria. So if I say Austria, then I can say, okay, I can use this and say, okay, run it on workdays in Austria. So whenever there is a public or bank holiday in Austria, it will not run. I can also select the time zone, the project, any specific additional input values that I want to pass on to the execution started by the scheduler, how many times it should run before the schedule says, okay, I'm finished, I'm done. Whether or not errors should be propagated, how long it should try to start the execution before it fails. So if it waits for more than 10, tries to start an execution for more than 10 minutes, but for some reason it can't. Maybe there's high load on the system, maybe some preconditions aren't met, then I say after 10 minutes I don't want it to run because then the window of opportunity has passed maybe. And whether or not it should fail if the max delay is exceeded. So this is already a fairly complex scheduler that can already do a lot of magic and has a lot of options. This is a summary, and then I just confirm and I'm done and I have my complex schedule set up. Wonderful. So I scheduled it for 2 times 8 to 1 and 8 to 2 on the next on every day of the week. It only shows the next 10 runs. Obviously it will continue to run after that, but we don't want to run print here. This is just a success message of setting up the schedule. I don't want to print everything like until the end of time, so it only ever prints me the next 10 runs. So this is all based on flow scripts, so you can determine any custom logic that you like. For example, a scheduler that calls a weather API and says, okay, I only run this when the sun is shining or when it's raining or when the degree or when it's between 20 and 25 degrees Celsius or whatever you like, really. So again, a very powerful scheduling feature. And I think for now, that's it. That was the full feature overview of Cloudomation Engine. I hope you enjoyed it. Get in touch, check out the docs.cloudomation.com for more information, and get in touch via our website or via info@cloudomation.com if you want to learn more. Bye.